All right, in this video, we are going to do the curve sketching algorithm for this question over here. And this is a very interesting question because we are going to have a vertical tangent in this question, which is generally not a grade 12 question, but it's something you might see in a very difficult grade 12 class or in an AP class. Now, luckily for us, they've given us the derivative and the second derivative of this equation, so we don't have to waste a ton of time calculating those. But nevertheless, this is still quite a difficult problem. So the first thing we're going to do is we're going to do our asymptotes, and we're going to do our x and y intercept from the original function. Let me start with the x and y intercept. So for the x-intercept, I simply have to make y equal to 0 and solve this. Now, technically, you should be able to do this straight away in your head, but I'm just going to show all the steps here for anyone who might get confused. Cross-multiply this with 0. I cube both sides, which means that my x-intercept is just -1. Again, you should be able to tell this straight away from just looking at this equation. Bottom disappears. Solution to x plus 1 cube root is just -1. For the y-intercept, I'm just going to replace the x's with a 0. You can either do this in your calculator or you can do it mentally again. Pretty simple. You'll just get a y-intercept of positive 1 if you sub in x as 0. So next, let's talk about our asymptotes. In this question, either x can never equal to 0, which means there are no vertical asymptotes. For a horizontal asymptote, this is not a general rational function here, so it's a bit hard to tell whether we have a horizontal asymptote or not, but as we'll see later in the question, we will have a horizontal asymptote in this example. Because generally speaking, when you have either x in the denominator, it is going to create a horizontal asymptote at typically one of your n behaviors, not both, because the exponential function is relatively flat at one end and shoots up to infinity at the other end. So you'll generally have a horizontal asymptote at only one of your two n behaviors, either the left side or the right side, but we'll discuss that in more detail as we do the sketch later on. To find the critical points, again, this is pretty simple. You want to just sub in 0 for f prime of x. Denominator just multiplies with 0, so it disappears. And then again, technically in this question, you should be able to tell it straight away. But if I divide both sides by negative, move the 2 to the other side, and then divide by 3 on both sides, I'll get -2/3 equals to x as my critical point. Again, you should be able to tell this instantly from the question, no need to actually show the steps in a test. I don't believe so, at least. Once we get the critical points, we want to find intervals of increase and decrease. But something we notice over here is that while the original function did not have any vertical asymptotes in the denominator, if you look at the derived and the second derived function, but most importantly, the derived function, there's a restriction in the denominator. So since we have a restriction here for our derived function, where x cannot equal to -1, this is going to create either something called a vertical tangent or an edge. There's two possibilities. So if your original equation does not have a restriction, but your derived equation has a restriction, that's where it creates a vertical tangent or an edge. If the restriction existed in both of them, it would just be a vertical asymptote. So now we have this restriction here. We also have to classify this restriction. Let's start with just doing our number line to figure out our intervals of increase and decrease first. On your number line, you want to put all vertical asymptotes, all critical points, and also all vertical tangent / edge restrictions. So in this case, we have Oh, I don't know why I put 3. We only have 2, as there's no vertical asymptote here. So -1 and then -2/3 are the only two possibilities on this. Then I want to test in values into my function over here. So I'm going to start by subbing in -2 into this equation. You can do it in your calculator. You could also do this mentally, I believe, because denominator is squared, which means denominator is always positive, and either anything is always positive. So my entire denominator is positive for the entire thing. Doesn't matter what. My denominator is positive everywhere, which means the sign is only based on my numerator. And if I sub in -2, so 3 times -2 is -6, plus 2 is -4. Negative of -4 is +4. So this is positive, which means this is increasing over here. Next, I'll sub in -0.9. Bottom is positive for sure. Top will be 3 times -0.9 is -2.7, plus 2 is -0.7, times negative is positive 0.7. So increasing again, and then I'll sub in 0. If I sub in 0 here, I'll get a negative value for the whole thing, which means my graph is decreasing. So now I can classify my restriction and I can classify my critical point as well. Let's start with classifying the restriction first, that appears first. So if you have increasing and increasing or decreasing and decreasing, that is a vertical tangent. So in this question, we have a vertical tangent. X value is -1. If I sub in the -1 into this whole equation here, I'll get a y value of 0 because it's the same as my x-intercept. So I have a vertical tangent at -1 and 0. Basically, if it's increasing, increasing, decreasing, decreasing, it's a vertical tangent. If it's increasing, decreasing, or decreasing, increasing, that's going to create something called an edge, which is slightly different. But a vertical tangent just means we have a tangent line that goes perfectly vertical at this point over here. This over here, this critical point, I can easily see this is a maximum. The x value is -2/3 or -0.67 if you're rounding it. Find the y value. I'll put this into the original equation here. I'll do this in my calculator. And if I do that, I will get 1.35. I round to 2 decimal places. So now I've found all my critical points and my vertical tangent slash edge. I can go to my inflection points next. So I'll go to the second derivative here. I want to make this equal to 0. Bottom's going to multiply and just disappear as well. So I just have the top over here. This can't be factored regularly because 9 multiplies to 9 adds to 12 is impossible, which means we've got to do quadratic formula. I'm going to squeeze in over here. 12 squared minus 4 times 9 times 1 divided by 2 times 9. It's -12 plus or minus root of something minus 18. So I'll do this in my calculator again. I'll round to 2 decimal places because writing an exact value is kind of annoying for these questions, although not impossible. Some teachers may ask it. I'm just going to do decimals here because that's a bit easier. I get -0.09 if I round the first one. And the second one is just -1.24. So I have 2 inflection points over here. My first inflection point is -0.09, and I gotta sub this into the original equation to find the y value. If I do that, I will get 1.06. And second inflection point is -1.24. If I sub this in the original equation, I will get -0.05. 2.17. Then I can find my intervals of concave up and concave down. So remember that we have to put vertical asymptotes, inflection points, and also edge points and vertical tangents if they exist in this. So I'm going to start with negative 1.24, my lowest inflection point. I'm going to go to negative 1, which is my vertical tangent. And then I'm going to go to my negative 0.09, which is my second inflection point. I'll pick a value lower than this, sub into my second derived equation. So if I sub in negative 2 into this whole equation over here, I will get a negative value, which means it's concave down. Next, I'll test negative 1.1. If I sub in negative 1.1 into this equation, I'll get a positive value, which is concave up. If I pick negative 0.5 and sub it into the second derived equation, I will get concave down again. And if I sub in 0 into the derived equation, I'll get a positive value, which is concave up. So now I have all the information I need to do my sketch. So start by putting all my important points. X-intercept, which is basically my vertical tangent, is at -1. Y-intercept is at +1. I have a maximum at -2/3 and 1.35. I have an inflection points negative 0.09 and 1.06 right there, and negative 1.24 and negative 2.17 is down here. I'll label all the points after I do the sketch because it's a bit more neat like that. And now we can start sketching things out. So I know the graph is concave down and it's also increasing from negative infinity till -1. So this is all concave down and increasing. And this is my point, my first inflection point of negative 1.24 and negative 2.17. Then it's still increasing. There's a vertical oh no, the vertical tangent is not here. This is just a regular inflection point. So comes concave up, and still increasing. So it hits this point over here. And over here, we have a vertical tangent at -1, which means the graph is basically at this point, the graph is perfectly vertical. Then we have it switching back to concave down again, but it's still increasing. So this point over here, which is our maximum of -2/3, 1.35. It's going to switch to concave. Oh no, it's still concave down all the way till -0.09. So this is all concave down over here. That point is my second inflection point, which is -0.09, 1.06. And then it turns to concave up for the rest of the graph. Now, since it's concave up here, we know it's going to have a horizontal asymptote somewhere. I'm going to label this point first as +1, my y-intercept. So to figure out the horizontal asymptote for this part of the graph, You can just plug in any large number like 10 or 100 or 1000 into the original equation to find out what the positive end behavior is going to be. You can also tell directly in this question because the graph at the bottom is just e to the x. I know e to the very large number means that this is going to be like really, really big, much bigger compared to the top, which means it's going to approach zero. But I would suggest plugging in either 10, 100,000 in the calculator. You should get 0.000 some small value. In this case, it's 0.0004 if I sub in 10. So I know that I'm going to have a horizontal asymptote at y equals to 0. And this is the entire function for this question over here. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.